Although the concept of the tank was first conceived by Leonardo da Vinci many centuries ago, it is from the First World War that we can trace the origins of the modern tank. After the initial German advances into France, the great armies of Europe faced each other across the long, static lines of the Western Front. After 3 years, millions of men had died in the continual effort to break through. The strategists reasoned that if only sufficient numbers of men moved to the front and charged once more against the machine guns and barbed wire, they were bound to get through. But again and again they failed. The stalemate continued. For many months, a few innovators in the British Army had been working on a solution: a mobile armored vehicle which could carry enough firepower to destroy machine gun emplacements as it led the troops through the lines. Finally, in September 1916, the British launched the first mass attack with the new weapon. They were called tanks, a term Army intelligence hoped would deceive the Germans into thinking these new machines carried only water for the troops. The engagement was a brilliant success. In a war that had dug in, settled down, and taken cover behind hundreds of miles of trenches, the tank, however primitive, could actually break through, opening the way for the infantry. While England continued to develop more efficient models, the French and Germans were soon producing their versions. The Italians were quick to pursue their own tank program, which included some rather vigorous field tests. Perhaps they expected too much. The final year of the war proved the enormous value of infantry and armored cooperation. The tank had brought back movement and mobility, once denied by trench warfare, and it reinstated this movement with a merciful cut in casualties. In 1916, during the first few hours of the Battle of Somme, the British lost 60,000 men while advancing only a few thousand yards. While at Cambrai, with strong tank support, only 9,500 men were lost during an advance of 10,000 yards. It was a new era of warfare, although it still remained for Hitler, 20 years later, to convince all those who still swore by the cavalry. The tank had been designed to break the stalemate, but when it helped force the Germans into full flight during the last weeks of 1918, it was obvious that this tough but sluggish vehicle would have to be reconsidered and improved in future years. During the 20s and 30s, the major powers continued to develop the new weapon. At Aberdeen Proving Grounds in Maryland, new designs, ideas, and better equipment were worked on. The hull was modified, and various solutions to the difficult problem of suspension were sought. As the Allies worked under the limitations of a peacetime budget, the German army secretly prepared for war. Colonel Guderian conceived the true role of the tank in the modern army. His idea was to force a lightning decision by committing masses of tanks in combination with motorized infantry, artillery, and aircraft. This was the revolutionary tank school of warfare. When the war finally arrived, theories suddenly became realities. Poland was overwhelmed by the speed and striking power of a modern mechanized army timed for a war of movement, the Blitzkrieg. When the Panzer Division struck a few months later at the Low Countries in France, they swept the defending armies out of their way. In a few weeks, the Western Front had fallen. The world had changed greatly since the days when the great armies clashed in 1914. During the long years of the war, each nation worked to improve their tanks. The Russian T-34 carried a powerful weapon which inflicted heavy damage. The United States M3, General Grant, played a key role in the early years, but the side mount of the 75mm gun provided a limited field of fire. Newly developed British models proved to be the key to victory at El Alamein. The M4 General Sherman, the first medium-type tank to carry its main gun on top of the hull, possessed the mobility and firepower to break through defenses with swift and telling effectiveness. The trenches no longer sheltered regiments of huddling men. The infantry, artillery, and engineers had mobility and security of movement never known before. During the last years of World War II and in the late 40s and 50s, the United States developed several improved tank models. But the main emphasis of our defense policy was devoted to the perfection of nuclear weapons and the capability of delivering a fatal blow to any potential enemy. The armed forces developed increasingly sophisticated missiles, and the race for space committed the United States to a heavy program in this new technology. These developments supported the policy of massive retaliation, which President Eisenhower and his advisors believed would deter the Soviet Union from any act of full-scale aggression. However, the challenge of communist-inspired local conflicts, or wars of national liberation, required a more flexible response and conventional weapons. At the vast tank plant in Detroit, Michigan, plans were formulated to meet these new demands. A new tank, one of many, the M60, had to be developed and produced. Engineers from the Army began to work on the designs with specialists in research and development. After many months, they came up with the final blueprints. A prototype was built and sent to government proving grounds for testing and evaluation. First, the M60 and later the M60A1 proved that these models had achieved a high degree of protection, firepower, and mobility. It was simple to operate, durable, and reliable. It had to be all these things to meet the requirements as the Army's primary assault weapon. The firepower consisted of a 105mm cannon and 2 machine guns. All weapons can be fired from within. A computerized fire control system brings the full fury of the tank's guns on any target with telling speed and accuracy. For many months, the tank underwent a vast variety of tests. It churned through grinding sand, which would quickly have reduced a lesser vehicle to a pile of clanking rubble. The M60 is powered by a 750 horsepower air-cooled diesel engine, capable of moving the tank some 300 miles without refueling. Day after day, it thundered through muddy swamps and across washed-out gullies, always moving under perfect control, while the continual check on brakes, acceleration, and the control system went on. The vehicle can easily cross man-made obstacles. It can climb vertical walls as high as 3 feet. It remains completely leak-proof as it travels through 4 feet of water. At the conclusion of the test, it was judged that the new tank had met all the requirements to become the Army's main battle tank. It was ready for production. Center of production for this mammoth job is the government-owned Detroit Tank Plant, which is operated by the Chrysler Corporation and supervised by the project manager, M60 Tank, for the United States Army. Organization is on a vast scale. More than 500 separate companies in 25 states and Canada supply the equipment for the tank, which is assembled at the plant. This scene is repeated many times as separate groups of engineers develop every detail of each component. Product improvement never stops, even though tanks are rolling off the assembly line. It takes a whole department merely to keep track of the constant engineering refinements, notify the right people of the change, and make sure it appears on every tank built after a certain day and hour on the production line. It's a complicated proposition because a crucially important change in one part usually touches off a series of minor changes in related parts. The hull starts out as a cast steel shell, but shortly every inch of it will bristle with all kinds of complex and vital equipment. This particular hull is the master. It serves as a checkpoint for all others and as a pattern for the fixtures. The accuracy of each fixture must be constantly checked against the master hull. At one point, the welders work as a coordinated team on both inside and outside. The hull is placed in a cradle, which can rotate and hold it in any position to eliminate the hazards of overhead welding. Inspectors check the 500 weldments. After inspection, the hull is then painted. The overhead cranes easily move the 12-ton hull. The 1.5 million square foot tank plant has produced over 35,000 tanks since it was built in 1940. At another station, most elements of the suspension system are installed. One of the 4 torsion bars is inserted, one end being secured to the hull, the other end to an arm which carries one of the wheels. Friction snubbers and track support rollers also go on at this station. The line is planned so that work goes on in all sections of the hull simultaneously. From here all the way to the end of the line, a bank of drawers feed the tank its seemingly limitless supply of parts. Finally, the power pack is placed into position. The work is complete on the hull when the track is attached. Now the vehicle can power itself through the end of the line. While the hull has been in process of assembly, the turret, which is the fighting center of the tank, has been receiving all its complex maze of equipment. Here, the tank gets its 105-millimeter gun. But the gun would be useless without a network of sighting, sensing, computing, and signaling apparatus, which must be painstakingly checked and tested. The gun is in line and on target. Now it is time to join the turret and the hull. What tank builders call the marriage. "48 bolts under 90 pounds of compression assure that this marriage will last. The tank is completed, but it is still far from being accepted by Army inspectors. Trial runs are conducted by experienced test drivers. "15 miles at low speed. Followed by 15 miles at medium speed. Then 15 miles at the top speed of 30 miles an hour. The first 45 miles is called the break-in run. It is the first phase of a rigorous testing and inspection program. The tank climbs a 60% slope and stops. It is run for 2 minutes, turned off for 2 minutes, and then must start again in 1 minute. A similar test on a 36% slope makes sure that the fuel will continue to feed the engine in extreme positions. The tank must not only be watertight, but airtight to safeguard the crew from chemical gas attacks. Every tank goes through similar tests, which are evaluated both by military and civilian inspectors. After the tests have been checked and approved, the tank is ready for shipment to our troops. They are loaded onto specially designed flat cars and transported to bases in the United States or ports for shipment overseas. The designers and builders of the M60 series understood the need for versatility and adaptability. They saw other needs for the tank. The basic M60 chassis has been adapted to other important military uses. This armored bridge launcher produced at the Detroit tank plant demonstrates its rather unique value. The overall performance characteristics are equivalent to the main battle tank, but the turret has been replaced by the bridge and hydraulic launching equipment. With a crew of 2, the vehicle can launch or retrieve a 15-ton scissors bridge in just 2 minutes. The bridge folds at mid-span for easy transportation on top of the vehicle. Speedy and efficient, the launcher provides an important addition to today's fighting force. Another application of the M60 chassis is the combat engineer vehicle. Equipped with a hydraulically operated bulldozer mounted on the front of the hull, the tank can perform a variety of tasks, including the removal of roadblocks, filling in gaps, ditches, and craters, and for general demolition and construction work. Carrying a crew of 4, the vehicle operates in forward combat areas, where the heavy armor provides protection against explosions, small arms fire, and shell fragments. A 165mm cannon, designed to fire at short ranges with extreme accuracy, can be used for demolition work. The M60 demonstrates its effectiveness in action during combat exercises. Over the past few years, the M60 and M60A1 tanks have achieved an outstanding record of performance and reliability. As they move in a coordinated attack with infantry units, the tanks meet heavy fire from enemy tanks and anti-tank guns. The M60 responds immediately with pinpoint accuracy. Equipped with an advanced fire control system and 105mm cannon, the M60 series tank can destroy targets at sufficiently long ranges and in such numbers that the full effect of the tank's smaller weapons can be brought to bear on the remaining enemy. There is no question but that it is an impressive weapon, but it is also a highly versatile weapon system. To give the tank commanders their choice of infrared or visible light to use as the situation dictates, a dual searchlight has been developed. The xenon light can be converted quickly to infrared, enabling the crew to zero in and destroy an unsuspecting enemy in the dark, as well as observing about at night without being observed. Another versatile feature of the tank is the water fording kit. After the tank has been properly sealed and the kit assembled, it is able to negotiate lakes and rivers up to a depth of 13.5 feet. The open conning tower serves as an observation and guidance post for the commander, as well as an intake duct to provide air for the crew and engine. More like a submarine than a tank. The ability to continue the attack in spite of waterways which once proved a formidable obstacle is a major advancement in the continuing development of the tank. Through a slow and evolutionary process, the Army developed its impressive main battle tank, Today, the constant search for refinements and improvements continues. The Army is now concluding the final development of a more advanced and versatile weapon, the missile-firing M60 A1E1. Today's tank is but a distant relative of those primitive vehicles that first crossed the muddy fields of Flanders 50 years ago. As the developments continue, the tank will remain one of the most important weapons in our arsenal of defense.